So Dominic, this is the really interesting aspect. This is the CAM environment. Maybe you could walk us through what's happening on screen and what these, all of these areas dictate or do.
As you can see here, Paul, we are now in a CAM environment where we do the turning side of it. The example that you see on the screen is our max turn that we are using, which is a round insert, we always recommend. And where you see the green surface, that is the stock removal. That is what the software is showing that it will remove on this tool path.
So what would be determine the depth of the cut that's happening?
We call it the in-feed factor. So as you can see over here is the in-feed factor of 0.3, which is normally calculated around the percentage of the tool radius.
Okay, and what about the actual speed of the process? So the speed the tool's moving, the speed of the spindle, what determines all that? How's that algorithm worked out, if that's what it is?
Yeah, we've got a formula that we use, that we always use the VC that's provided from the tooling supplier. We have a general rule of thumb that we say 1.3 on the RPM, which is your G96 line. And then we also have the feed rate that's calculated in the background that we give a formula of 2.5 over the feet per revolution.
Okay, now I want to know more about this area as well here, because this is the zigzag that we've been talking about.
That's correct, yeah, that's correct. So what you see here, at this moment, the strategy is set to linear, which is the norm that you see on most CAM environment that people are using. And then you have also got the ramping, as well as the zigzag and machining angle that you can use. So what I can do, Paul, I can show you, if I flick between them, how the image changes. Then it gives you a better understanding of what it's doing. So as you can see now, it's set to linear. I'm just going to switch it over to ramping to show you how the changes. So now you see a ramping. So that image has now changed. So in linear, it will always machine towards the chuck, and then I feed back to the starting point, then feed in again, and then I feed out again. When you change it over to a ramping, which is an extra area that we've got on top of our max turning environment, is what it's doing now, it will do a feed towards the chuck, and if you have a tailstock support on here, the feed will now also reverse feed. So now you have a constant cut. So what happening now, the tool stays in inclination at all times with the ramping. So you are now taking your tool path to the next level in the max turn environment.
Now, what about then if there's certain features around here that you don't want to have to come back to go back to, if you see what I mean?
Yes, this is what you were saying. This is where the zigzag kicks in. So what's happening now, when the tool is cutting in the ramping environment, it's cutting forward and reverse, if that's a term we can use. And once you switch on zigzag, the tool will cut forward. If it sees in a dense area that you're cutting, the tool will force its way down if it can. It will recalculate itself to find the dense area, and the zigzag will solve that problem for you. So now you get even less of a high feed move out.
So you're improving your cycle time by your linear motions backwards and forwards,
yes,
but then you're furthering that one step further.
That's correct.
By your zig, and correct me, it's called on here, it is the zigzag function.
That's correct.
Is this unique to hyperMill?
Yes,
this
that is unique to us. Yeah, this is where it's you get a very norm that you get a linear and a zigzag on CAM. We are unique with ramping and zigzag.
Okay, right. Can we just see this doing the motion as well?
Yeah, of course. Let me switch on the tool path that we've got ramping on. Yeah. Speed is.
I'm always fascinated by how easy these sort of platforms are to navigate and then to simulate, to really give you a feel for what's happening in the machining environment here.
So as you can see now, Paul, what it's doing, it's constantly staying down in these areas here on the ramping. Because of the ramping and the zigzag, you get minimum lifting in these areas. So take, for example, this was more of a dense radius, where it's more rad for rad to the tool. That area there, when the tool feeds back into the ramping, if it sees, hold on, I can come down here, it will go down.
What's this indicator on the yellow on the button there?
That is what we call the cutting point in turning. So when you simulate, you know exactly where your cutting point is, where you set it on the Q setter. So that is like you set it on the front face and on the bottom of the radius. If I use if I were doing using the back end, say maybe on the sub spindle, then that point will be on the back.
And what about the wear on this insert here then? It looks like we're very focused in certain areas. Just obviously that will mean that those areas will wear faster than the other areas of the tool.
Not necessarily. Again, this is where the infeed factor comes into play. So your normal cut would be, say for example, I'm doing a 1.2 depth of cut. Now I'm getting into dense areas. The infeed factor will decrease. So instead of a 1.2 depth in the condensed areas, it will now adjust it to maybe a 0.8 or maybe a 0.6 or even less.
Okay, now I know we've got lots of questions coming in. We're going to get to those shortly when we're going to be seated back down, and we'll answer some of those, but do keep them coming in. Let's finally talk then here about the actual insert on the tool. This is a Seco tool, is it? Do you favour any specific brand of tool, or can all manufacturers of this sort of insert achieve these results?
Nowadays, we are using a Seco, but I don't really see there's a limitation to who you're using. It's maybe the type of tool you want to use. Maybe if you can use a solid grooving insert, if you can use that with a full rad. Because the thing is, when you bolt it down, it's more robust, so you can hit it a lot harder.
Are there any negatives to this strategy? We have to look pragmatically.
Yeah, 100%.
Is there any areas that people just have to think about?
For example, if you use a tool where you use a screwed insert, where you screw it down, you can't use ramping. Of course, what happens when it machines towards the chuck, the insert tightens. When you machine with ramping, it will machine forward and reverse. So what happens now? The insert loosens, so the screw loosens up, so you might blow your tool. When you do use ramping with an insert, with a screwed insert.